some brief introductions. So before we jump into that, I nearly finished working through marking everybody's research assignments, and let me say, I'm just loving what I'm seeing there. Very creative, very informative, technically sound stuff coming in. We'll be finished that. I'll be finished marking them all shortly. Then I will give out some prizes next at the start of next session. At the end of this session, I'm going to be giving you a small desktop assignment, and then after the end of next session, we're going to give you the actual audit assignment where you'll have a site to go to and the like. But this session, we have Fergus Tate, and many of you will know Fergus or know of Fergus because he's a bit of a legend of road safety in New Zealand. He's been around a couple of years, and before his role with WSP, where he's he's technical director, he was with Wakatahi as lead safety advisor, I think was. Oh, there we go. We've got it all up there. Lead safety advisor, technical development leader at MWH, and lots more on there. And PhD over in England, am I right? Is that where you did it? Leeds?
Yeah, Leeds.
And what was the topic of your PhD again? Remind me.
I was actually looking at the safety impacts of an intelligent junction warning system. It had very, very good safety impacts in one area and absolutely disastrous in another. And one of the great things about being at Leeds was I was the only engineer in the road safety unit. Everybody else was psychologists. So I learned quite a lot of road safety psychology while I was sort of by osmosis, I suppose. But it's certainly the SIS scheme that I looked at failed abysmally in terms of driver behavior and mental workload and things like that. So yeah, it was a really broadening time.
There you go. It does sound fascinating. And Ferg is certainly somebody worth sitting down for a coffee or a beer with and having a good chat about all sorts of road safety topics. But we've asked him to come along today to present on the sort of technical assessments, road safety auditing of those technical designs and some technical elements in there. And in your slides and on the screen now, you can see Ferg's contact details. If you did want to follow up and have a bit of a chat with him about anything there, you've got the email and the phone number and the like. Now, I'm going to be behind the scenes so pop your questions into the chat as we go. I'll feed them through to Ferg, and we've got a few polls. We'll have our stretch break in about an hour. So over to you, Ferg.
Okay, well, thanks, Ken. As Ken said, at the end of this module, I've tried to collect things that I think are important as we go through. Things like what happens if you violate drivers' expectations. How does crash migration occur potentially? And those are particularly pertinent to rural road issues. Then looking at things like design vehicles and check vehicles, which apply to both urban and rural, and then looking at some of the things that occur around sight distances in the urban area. And finally, I want to finish off looking at the information for safety audit at the detailed design stage and the role of the prompt lists. I think the really important thing with any safety audit is actually understanding the scope of the project that you're involved in and making sure that you and the audit team members have actually got the skills to cover that scope as you go through. So it's quite important. So I want to kick off first of all looking here. The Guide to Road Safety Part 6 talks about safety audits and identifies 4 stages of safety audit, I suppose. The feasibility, the preliminary and the detailed design and the pre-opening. And I've got a little poll here, which if I can find it and bring it up.
I'll bring it up on screen and you'll be able to see it right away there, Ferg. It'll be right.
Okay, thanks, Ken. Thank you.
There we go.
So what do you think is the easiest stage to audit? You've got a single choice, and if you pop that in your Menti, that would be really good. what do you think is the easiest to audit?
Okay. So we're seeing some people popping their thoughts in. We will give it a second here, and a few people, well, lots of answers coming in. Give it 5 more seconds. 4, 3, 2, 1. Remember, you're not marked on these. And I'm going to stop, and we'll share results with everybody there. So looks like for most people are saying pre-opening, closely followed by preliminary design. And only a few people are saying detailed or feasibility stage. Over to you for your thoughts.
Yeah, well, I agree. I think when you're looking at the pre-opening or the post-construction, it's very concrete. You're looking more or less sometimes at a snags list and things. It's far more difficult to do the feasibility stage and the optioneering, and that's actually an area where using things like the Safe System Assessment Framework and that option selection plays a much bigger part when you're back in those early stages. I actually disagree slightly with the poll, because I think the next, I think it gets increasingly easier as you move towards post-construction. So I think the detailed design is actually easier than the preliminary design, because the detailed design, again, you've got something that's far more concrete in front of you that you can work your way through systematically. One of the things that I find when I'm doing the audits, particularly in the design and post-construction, is getting the evidence for the audits. And I like to be able to tell the story of why something is. Just because I don't like it, I don't like the way somebody's done a design, doesn't necessarily mean it's bad. You have to be able to tell the story. You have to say, I don't like this because it's going to have this impact, which will result in more deaths and serious injury. And if that story becomes more and more convoluted in order to get to death and serious injury, you know, like it has to be a Wednesday at 3 o'clock on a snowing afternoon, and then if this happened and that happened and something else happened, then you might end up with death and serious injury. If the story becomes long and convoluted to get to that point, you've really got to ask yourself, was it real? You know, and I think, you know, particularly as you move across, when you're in those earlier feasibility stages, you've got a lot of imagining to do, and you've really got to ask yourself if it's real. I want to start off now talking about drivers, and I don't like necessarily reading off slides, but these are 3 quotes from US Highway Agency document from 1997. And drivers generally make fewer errors at geometric features that conform with their expectations than at features that violate their a priori or ad hoc expectancies. So in other words, if drivers make fewer errors when things conform to their expectations than when they don't. So if they're thinking something's going to happen, and that happens, that's fine. If they think something's going to happen and it doesn't, there's more chance of it ending in an error. If a road design is consistent in design, then the road should not violate the expectations of motorists or inhibit the ability of motorists to control their vehicles safely. So again, consistent design feeds into that idea of making less errors. And consistent roadway design should ensure that drivers would be able to operate safely at their desired speed along an entire alignment. So the key thing here is, does the design that you're looking at feel consistent and send the right messages? And there are a number of things where we design or we have features that don't follow these principles. In particular, one of them is curves. And I'd like to have a look here at curves, because I don't know what it's like in Australia, but in New Zealand, the bulk of our crashes occur on curves, on rural roads. Intersections and curves are the 2 biggies. And there are 2 types of curve that violate drivers' expectations and increase the likelihood of making mistakes. Those are curves that are difficult to read and those that are out of context. Now, the curve negotiation equation says that E, which is the super elevation, plus F, which is the friction, resist the forces from speed and radius. And I've got a little poll. Ken, can you bring up the poll, please?
Yep. Here we go. Launching the next one.
Okay, so of these 4 factors, which has the most influence on driver negotiation, on curve negotiation?
So remind us what E.
So E, we've got the super elevation or the camber of the curve. F, we've got the friction of the pavement and the tire. V is the negotiating speed, and R is the radius of the curve.
Okay. All right. People are pondering that and popping in their thoughts and ideas. We'll give it another 5 seconds on this one. 3, 2, 1. Almost got everybody there. I'm going to end that and we'll share the results. Most people going with V there.
And closely followed by R, which is really good. Yes, when we're looking at a curve, drivers can't see F. They have no idea about what F is. You know, they can feel E once they're in the curve, but their curve negotiation speed V, which is critical to them coming off the road, is more set by R, the radius. So V and R are the 2 greatest components that you have. And when we have a look at curves that are difficult to read, here is some data that we collected, Dr. Shane Turner and I collected some years ago on a bunch of curves. And what we're looking at here is the minimum radius of the curve, which in this case is 300 meters I'm looking at here. And the design speed of that curve could be anything from 60 to 100 kilometers an hour. So because of E and F that the drivers can't see and understand, their speed choice could be anything in this range. And if they assumed that the design speed was 100 kilometers an hour and it was only 60, then she's all over Rover, as you were. So it's very important to understand that it's actually the radius of the curve that has the biggest impact on driver speed choice, which is what I'm showing here. So this is the mean curve speed of the sample of drivers, and this is the minimum radius of the curve. And you'll see that there's quite a strong relationship. There's quite a flat bit through here, down to about 300 meters. And then it tails off as the curves get tighter. Now there's a group of curves that typically sit here between 250 meters, sometimes 200 meters, depends on who you're talking to, and 500 meters or 450 meters, where effectively drivers are not changing their speed from the approach for those curves. But as I showed you up here, that 300 meter curve could have a 60 kilometer an hour design speed, and yet they don't change their speed of approach. So these curves trap drivers and things, because drivers rely on radius more than anything else to determine their negotiation speed. And so here we have the minimum curve radius for this 300 meter curve against the 85th percentile speed for that curve. And there's quite a substantial difference going on in here, almost 20 kilometers per hour. So the big thing is to try and stay away from radii that sit in this range from about 450, maybe 500, down to 250, maybe 200, in that area there. And in fact, the New South Wales guide actually talks specifically about these curves as being curves that are hard to read and things. So it's difficult for drivers to assess what the design speed is for those curves and to behave appropriately, because it's possible that the curve could violate their expectation, particularly if they've driven through a whole lot of 300 meter radius curves that have got a design speed that's higher, and then they get another one that looks the same, but the design speed's lower. So it's quite important that we try and avoid those sorts of curves as we go through. The other thing that we find is that the crash rate per 100 million vehicles entering the curve obviously increases with the length of the curve quite substantially. So if you've got one of those curves and it's a long curve and you go into it too fast, the chances of you getting out the other end of it in one piece are greatly reduced, because when you've got short curves down in this area down here, you can more flat line them and it's not so bad. But if it's a long curve that goes on and you make an error of judgment entering that curve, then the chances of you actually coming out the other end safely are quite reduced, which is why this graph rises so dramatically. So the other thing with curves is the coordination. And here's a bunch of poorly coordinated curves. So this one here, we've got a hump, and then just beyond the hump, we've got a horizontal curve. So it makes it very difficult to see and things. So you don't know what's going on. In this case here, we've got a rail crossing just beyond the profile that makes it difficult to see and things. You know, how you actually coordinate curves is really, really important. You know, you really want to avoid two similar horizontal curves in the same direction, as this gives you sort of a broken back effect, and you need to separate such curves out by probably around 2 seconds of travel time. And you need to be wary when you're doing designs about optimizing the vertical profile. My friend Keith Wheel some time ago showed me a design that he was auditing, which I thought was fascinating. In a distance of about 800 meters, the designer had put in 6 different vertical elements. So they had 6 different vertical curves, and while that might have balanced the cut and fill, it makes it a really difficult alignment to read. And in some ways, it's a little bit like polishing a turd. Really, you're not actually winning a great deal out of the other side, because those incremental bits compared to a single curve are really quite small, and certainly smaller than you would in terms of the bulking factor of your earthworks. You're better to coordinate curves in this way so that you get a flowing alignment that people can see their way through and go. So the big thing so far is watch out for curves in that 200 meter radius, that 200 to 500 meter radius band. And then if you're in that curve space, making sure people can actually get the forward view to see what the forward alignment looks like. The other one that's really interesting is out of context curves. And this again goes back to the violation of expectations. Out of context curves are curves that are violating your expectations. And if we look at the difference between the approach speed and the curve speed and the crash rate per curve, where there's a little difference, so only 10 kilometers an hour difference between the approach speed and the curve negotiation speed, we've got very, very low crash rates. The minute that goes up to sort of 30 kilometers an hour, the crash rate on the curve more than doubles. So, you know, looking at that difference between approach speed and curve speed gives you a measure of how out of context the curve is, and that's strongly related to the crash rate, because you're violating the driver expectation. One of the things that comes up time and time again when we look at this business of approach speed and curve speed is crash migration. Too often we work on projects, whether they're realignments, passing lanes, any sort of shape correction and link width increases that increase the operating speed. They typically keep being built until they become too expensive to build any further. And so what usually makes them too expensive to build any further is something like a bluff or a deep fill or something. And so often what you find is that the scheme that you're doing finishes just before a really dodgy curve or a really dodgy narrow section or something like that. And because the work that you're doing is going to increase speeds, particularly if it's a curve, we're increasing the speed, the operating speed. Say we put in a passing lane, when we get a 20 kilometre an hour improvement because of the alignment, and then we get another 10 kilometres an hour because vehicles are overtaking and they're coming screaming off the end of the passing lane into a substandard curve, which we couldn't fix because it was too expensive, we will get crash migration. And one of the most frustrating things as a safety auditor is when you're sitting looking at a job and the first thing they say is, that curve's out of scope, the project only finishes here. And, you know, as a safety auditor, you are duty bound to look at the issue of crash migration. And the idea that just because the end of the seal that you're working on the project on is here, and there's something dodgy here, has got nothing to do with whether it's in or out of scope. You are obliged to make sure that it is in scope, because crash migration is a really real thing. And in fact, in New Zealand, almost half of the state highway passing lanes that were built in a study we did recently, when we looked 2 kilometres upstream and 5 kilometres downstream, almost half of them resulted in an increase in crashes, not a decrease in crashes. And that was particularly so downstream of the sites. Ken, you've
Couple of
appeared on my
questions have come.
screen.
A couple of questions have come in. Well, so one is, I'll come back to crash migration, but the first one was just around how the speeds were calculated for the curve speeds you were talking about. Were they actual vehicle speeds measured, or were those sort of ball bank tests or the like?
In these graphs here, the minimum curve radius was calculated using the curve equation. So that's the minimum negotiation curve speed. The approach speed in this case was actually measured in a sample of drivers driving those curves in an instrumented vehicle. The other one that we have done is looked at the relationship between the approach geometry, which is the geometry typically over the preceding 500 meters. And that was actually used in where am I? In the out of context curves. That was actually used for this, was an approach where we calculated the approach speed based on the horizontal geometry of the preceding 500 meters and the curve crash rate based on the geometry of the tightest 30 meters of the curve.
Right. Okay. Good. Thank you. Next question is around, where do you stop? Where do you stop? So this is back to what you were talking about for the crash migration. I mean, is it anything that influences, or anything you see on the way out to the audit site, or, you know, how do you draw that line of what would be included in your audit and what wouldn't?
Okay, what I would be looking at, particularly if it was looking at a realignment, I'd be looking at the first couple of curves downstream of the project. What you're really looking for is the situation where speeds are likely to have increased. So coming off the end of the project, if it's been a realignment or something like that, you will get an increase in speed. If you're joining another new alignment, that increase of speed will be trivial because it already has a high speed on the new alignment. If it's going back to an old alignment, then you'll get that speed differential. And you'd certainly look at the first curve and possibly the second curve. After that, basically you're saying if they've got through those two, then they're probably back to normal and things. Does that make sense?
Yeah. No, that's good. Okay, keep the questions coming in, everybody. Ferg, you can keep moving along.
Okay. I'm just going to talk more generally about safety audits as a whole, particularly at the design stage. I mean, there's a lot of stuff. A lot of people talk about the crash history and that you should have the crash history. You got to remember that a safety audit is not a crash reduction study, and neither is it a comparison with standards. You're asking yourself, what is it about this site that can be improved to improve safety? So it could be compliant in terms of standards. It may have no crash history, but you're asking yourself what things can be improved. But there's a lot of data that you can have, like the crash history at the site, which may indicate the types of problems that need to be solved, and previous audit reports, and the volumes of pedestrian and cycles and the types of people using it. But they're all about trying to understand what's happening at the site, and what the safety problems might be. Not, you know, Ostro says that this should be this radius curve, and in fact you're 2 meters shorter. I was doing some work in the UK a few years ago now, and one of the things that really frustrated me there was if you had a certificate of departure for a substandard radius, then it, in theory, didn't feature in the safety audit because you had a certificate of departure. The question should have been, from the audit perspective, is it sensible to have a substandard radius curve at this location? Not, I've got a certificate of departure, therefore I'm all right. It's, was this a really sensible design thing to be doing? So in addition to the drawings, you need to compile all of that range of data to help you understand the site and what sort of problems you may have at that site that are trying to be addressed. Now, who can tell me the difference between a design vehicle and a check vehicle? Any punters?
All right, let's see if anybody pops something in there. There's a question, while we wait for others to pop that in, there was a question that's come in. Out of scope concerns, how much detail do you suggest for these wider scope issues, and you've suggested mitigation needed? And you know, is suggested mitigation needed?
I believe so. I believe so. I mean, years ago when I first started safety auditing, Dr. Ian Appleton said the safety auditors should be reasonably confident that what they suggest can be implemented. So there's no point in suggesting a grade separated interchange on a road that carries 2,000 vehicles a day, because you're talking shit. What you need is, you need to be horses for courses, and that you should have an expectation that 90% of your recommendations are implementable. So if you bear that in mind, then you can think about what it is. Certainly at the feasibility stages, you can certainly look at those wider issues, and it's really important that you do, as well as, and the other thing I was going to say with the safe system assessment, I forgot to say this earlier, don't get tied up in the numbers. Everybody gets, nothing drives me madder at the moment than somebody saying that one's 64 after the event and this one's 63. That must mean that this one's better. The whole value of the safe system assessment is around the questions that you're asking yourself and the designers. The numbers are rubbish. Well, not really rubbish, but they are secondary after the event. And the other thing is, how you cut and dice the safe system assessment depends on the numbers. If I do a safe system assessment for this whole interchange, and somebody says, what happens if I turn this crossing from a staggered crossing into a single crossing? The safe system assessment is probably not going to actually show any change. If I broke the job down into all the crossings and all the other bits, the safe system assessment might actually show some change, but it's got nothing to do with it. The question is, should I have a staggered crossing at this location, or would I be safer without one? It's got nothing to do with the numbers. Sorry.
No.
That's a little hobby horse of mine. You probably have another whole session on it, Ken, but.
Well, we do have another whole course on safe system assessments, and we do reiterate exactly the points you're making. It was always a fear when putting numbers to this that people would use it in in the way that some people do use it. But yeah, we will move back to. I've got some answers for your design vehicle checking vehicle question here.
Okay.
We've got a few different answers, and you can pick one that you like very much, Ferg, and we'll give a prize. So we've got one that says design vehicle is the one using the site. Check vehicle is a check versus RTS 18. One just sort of talks about clearance envelopes, or just says clearance envelopes. And the third one to choose from, design vehicle is what uses the site every day. Check vehicle is maximum size vehicle that may enter the site.
Yep. I'm going with number 3.
Number 3. Okay. And
Number 3, please.
number 3 gets a prize. I'll organise that. Back to you, Ferg, to elaborate on that.
Yeah, I mean, typically the way I look at it is that under the road rules, the vehicle should stay in their lane. So the design vehicle is the most practical vehicle that should not encroach in the adjacent lane or shoulder. However, the check vehicle is there to assess what would happen if an occasional predictable large vehicle were to use the site. So it doesn't have to stay in its lane. So it might be something that goes through it off peak, or another time of the day. And I'm just pull my mouse over here a second. So in New Zealand, we typically use for the state highways a quad axle semi as the default design vehicle, and then we might check with 20 meter B train or 25 meter B train, depending on what was using that site by exception. So that's typically what we're doing. And what we're thinking is that you're unlikely to have those extra large vehicles. In many cases, they actually turn within the same parameters as the quad in most cases, but you're looking at them being used on occasion when other people can get out of the way. The other one, and you also need to check the sort of presence on things like vulnerable road users and transgressing into the shoulder and things like that. And in that case, one of the ones in urban areas is the single steer coaches, which actually are quite they're quite bulky, and they can actually often be a governing constraint. Issues with design vehicles, particularly when you're designing urban intersections and the like, is using the wrong design vehicle. Making sure that the swept paths are actually accommodated. And one of the key things with the swept path is the right speed assumption. If you ever get turning circles on a drawing, find out what speed they were. I've just been looking at a project the other day where a vehicle was going to pull in and do a turn, and I found that the swept path that he needs to make the turn without moving out of the lane is 5 kilometers per hour. So a vehicle was going to turn across 2 lanes of traffic, which in itself is a disastrous design. It's going to filter turn across 2 lanes of traffic and clear those in order to, and he's going to do it at walking speed, because that's 5 kilometers per hour. And interestingly, when we bang that up to 20 and 30 kilometers an hour, guess what? Couldn't stay in its lane, because and that becomes particularly important where you've got reverse lock turns, and the design or the turning circles have been done at low speed. It's really hard to go from lock to lock at higher speeds without drifting. The other thing that becomes really important is what I call the takeoff point, particularly where the takeoff point governs the curve negotiation further round the curve. Maybe on the exit of the curve, you've got to set yourself up perfectly at the start so you can get out at the exit, and yet you haven't seen the exit. So we need to have a look at that. So the sorts of things that we've got to watch out for is encroachment into the adjacent lanes, encroachment into pedestrian areas, and that's really interesting with buses. Frank Lai at Leeds University did a UK study on pedestrian impacts with buses. The biggest impact was the wing mirrors on the buses hitting pedestrians standing at the side of the road waiting to cross. Conflicts within the intersection and impacts with roadside furniture. Now I'm going to go through a few examples, and I think Ken's probably going to jump in as well as we go through these, but we'll start off with this one here. This one here is Preston Road and somewhere else, East Tamaki Drive in Auckland. And looking at this one here, this this truck cannot stay within its lane. Now you might argue that that's fine, it's a signalized intersection, but it's actually on a give way here. So in theory, it can move at the same time as this traffic stream, and yet it can't stay in its own lane. Here we've got this is a leading to an industrial area. So it is quite possible that you might have a single unit with a truck and trailer unit. They cannot negotiate those themselves and get round without encroaching on each other. Now, what would typically happen is one would drop back behind the other. So it's probably not quite so critical, but this one here certainly is. And in the Austroads guide, you know, you're talking about 2 meters clearance between these vehicles and 1 meter between vehicles in the same direction. So if I roll back up here, nothing like that's happening in this. So it's actually, although, you know, I'm not design guide driven, it's certainly something to have a look at in terms of what's going on and what the potential conflicts are and whether they could end up in sideswipe crashes as a result. This one here, this is an interesting one. Every time I see a swept path that does something like this, it rings alarm bells, because it's very hard. I used to drive a bus, so I've just recently sacrificed my license because I've got diabetes now. But in order for this vehicle to end up over there, it's got to do a very complicated series of maneuvers, which are going to make it very, very difficult. Because if I was driving that, I'd drive it as a single curve, and I would end up encroaching here. So somebody has worked out a convoluted tracking path through here in order to get that clearance between the two opposing turns, and that's really a sort of a made-up solution, if you like. It's not one that drivers would follow. Also, looking at the swept path around here, we've got issues where we have pedestrians waiting at the signals, as I said, and again, they're vulnerable to things like coaches and mirrors and the like as we go through. And over this side, again, the curbing is probably going to cop it as well. So yep, here's another one. This one, I think, Ken, is this is the bus depot, isn't it?
Yes, that's exactly right, Ferg. It's a new bus depot being designed, and sort of the car park bit there, and it's where all the buses are going to be going in and out. And as you can see there, there's some swept path challenges there mounting over the areas.
It's bloody near on the wall to the steps.
Yep, that's right. So and you know, that kind of stuff, I suppose, is a good highlight there of probably incorrect vehicle choice, where they may have said, well, a checking vehicle potentially is a bus. Well, that obviously is not going to be right to call a bus a checking vehicle in a bus depot. It would be a design vehicle. So, yeah.
And imagine that you're a visually impaired person who's standing here waiting on these tactiles, because that's where you're waiting to do. And then somebody comes and whacks you on the freaking head with their wing mirror as they make this ridiculous turn. So, you know, this is the type of thing that in urban areas that we've got to watch out for. Here's another one with parallel movements. Through here. You know, these movements can run at the same time, and sure enough, there's no, you know, you've basically got an overlap through this area here. And unlike the first example where I showed you where we had a single unit and a truck and trailer unit, and it's more than likely that if they were traveling in the same direction, they would stagger themselves and sort themselves out. These guys are coming from opposing directions. They've not got that option. So again, you've got a high chance of highly increased risk of sideswipe crashes, which are what you're, you know, again, with all of the things in safety audit, is what is the crash outcome that's likely to happen? These have got insufficient separation of the turning paths, and that's likely to lead to an increase in sideswipe crashes. Always have that reason back to crash type. Last one, this is roundabout near Masterton, which is a really interesting one because again, this guy coming in here, it's got a very strange set of maneuvers to get out. But I think the one that's really hardest is the truck, sorry, coming in here. He has to be right over here in order to get through there to make sure that he comes out here while crossing the island. So setting yourself up at the start so that you can exit safely it's very difficult for a driver who hasn't driven through this in the past to know that, you know, that they've got to be here, or they've got to start here, go to there, rather than just come in the middle and think that they're going to get through, and they'll end up getting trapped coming out the other side. This is another interesting one where the swept path of the bus, this is a turnaround facility on State Highway 2. This is a swept path for a truck, comes in here, if you can see my cursor, round and waits at the give way. Now, the vehicle that's likely to hit him as he pulls out is over here. And if you're sitting in a cab of a vehicle, you're almost certainly got to strain background if you can, or you may not even be able to see that vehicle because the stand-up point, if you like, is not compatible. Yes, it would be really, really nice to square that up so that they could look out their side mirror and see what was coming. But the minute you do that, then you can't actually turn this side of the wire rope barrier. So there's some issues floating around in here. So this guy, thinking about the safety issue, when they're parked here, they cannot adequately see the approaching traffic, and they may choose a wrong gap, which would end up in a crash. So that's what's going on there. There's lots of signs that you can see on site that tell you a design isn't working. Particularly if you're going out, you know, you can see the start of these when you've got things like post-construction audits and broken curb and dirt everywhere. This one here, I mean, the tracking is quite clear that in order to make the turn that's required, these guys have had to come right over onto the island. So these are all signs in the classic infrastructure. And things, the signs getting bold and things, not only, you know, somebody's now got to come back and put themselves at risk to set that sign up, and it'll probably get knocked down again and things. The other one that I want to talk briefly about, which is quite important, particularly in urban areas, is sight lines. And it's another area where it comes up regularly in safety audits, is that we don't have adequate sight lines to other road users, to other vehicles, and in particular in rural areas to the pavement, because the pavement is where the markings are, which tell you what it is that you need to do, whether they're lane markings or hold lines or anything like that. And when you're dealing with intersections in particular, you want the sight lines to a 0 object height so that you can see the pavement markings and know where you're supposed to stop, so you don't overshoot and put yourself at risk of collision with through vehicles and things like that. And there's a number of things that will restrict sight lines, and particularly when you're out on site, you need to be aware of some of the more dynamic things, such as shadowing vehicles, but also parked vehicles and things when you're out on site. And so, you know, typically these are the safe intersection sight distance requirements, you know, back 5 meters out to here to avoid the collision or the conflict point. But if you imagine a road like this, and I'm just looking at this one here, we've got an intersection here. You know, we can go back 5 meters and see how far, but we've got trees and obstructions through here. But when we actually have a look at this now, if you look just behind that Toyota before the Pajero, I think you can just see the roof of, you could just see the white bit of this bit here, I think, just is that it just there? That's giving you no time to clear the intersection. So, you know, you've got a sight distance problem there. The other one that you get, of course, is where you've got multi-lanes of traffic and you've got one vehicle shadowing the other, and you have problems. That often occurs with left turn slip lanes and through vehicles, and you think the vehicle's turning left and you pull out and the vehicle that's following just beside it cleans you up and things. There are heaps and heaps of different sight distances, and you need to work your way through all of them and things, but also have a think about what it is that, I mean, MGSD is quite a big requirement. It's the minimum sight distance based on the gap necessary. So what you can do in some situations is make sure that you provide as a minimum safe stopping sight distance. Interestingly, providing safe stopping sight distance above all else is effectively changing the priority at that intersection. Because what you're saying is, instead of the side road having to give way, if the vehicle moves into the traffic, then the through traffic must stop. So you need to ask yourself, how does that violate drivers' expectations? Do they have enough perception time and reaction time to do this, or should we be looking for a higher level of sight distance? Some of the common issues, how are we going for time, Ken?
Doing well, Ferg. You got you got plenty of time. Probably in about 10 minutes. We're going to give them a stretch break, unless you're.
Well, I'm actually going to be nearly finished, because I seem to have gone through it much faster this time. I don't quite know why. I'm sorry.
No, it's not a problem. They will. I've got a nice juicy assignment for them to get sink their teeth into. So they will use any spare time at the end to start that process.
Okay, then.
So we'll let you finish off, and then we'll have a little stretch break after you're done.
Okay, yeah, I'm sorry. I seem to have gone quite a lot faster this time, by almost twice the speed. Okay, common issues. At intersections, these are probably the common issues. See-through, that's where you're not looking at the current intersection. You can look straight through it and don't actually know that the intersection exists effectively, because you've got a line of sight through. That's quite common on grid networks, particularly, and it applies equally to rural and urban areas. The stand-up angle, as I said before, the angle at which a vehicle is stopped and where it's looking, and can it actually see? Sight lines to signals, roadside hazards. An interesting one is to the back of queue issues. Now, this is a classic where often to do with motorway ramps and things like that, which typically end in some form of traffic control. By the time you get a queue, and then you get the deceleration that you need to get onto the queue, you suddenly find that the vehicles on the main line of the motorway have to be decelerating in order to join that queue, and they may not feel comfortable doing so. It certainly won't be good for them to be dropping to 40 kilometers an hour on the main line in order to join the back of the queue. So understanding where the back of the queue is likely to be under different conditions, and then adding on to that the length that you need to decelerate in order to be clear of the traffic. Line marking issues, again, one of the big ones is actually sight distances to the line markings and things. This is an interesting one, the Danish offset, incorrect. That's for zebra crossing. So that's when you stagger a zebra crossing, you're supposed to go like that, so that and across, so that you turn and face the traffic that's coming. I've actually just drawn it the wrong way around. It should be that way. So that as you come across, and then you look towards the traffic that's going in there. That works. I've just done one recently where we changed it the other way around, and everybody said, oh, you can't do that. But we had to, because if we hadn't, we wouldn't have been on the pedestrian desire line. And in the end, we signalized the crossing, so it didn't matter quite so much. So, you know, it's like all of these things, you need to have a think about what it is you're doing and why. Paint for road hazards for motorcyclists and cyclists. In New Zealand, I don't know what it's like in Australia, we put out tourist arrows, particularly on roads with high tourist numbers, to stop the wrong way drivers, the tourists who are driving in the wrong lane. And one of the things is that those arrows that we're putting in the middle of the road should only ever be on straights, so that they're not in the cornering of motorcyclists, and that they should be visible for 300 meters so that the motorcyclists can actually see them and negotiate their way around them without abrupt turning and things. Islands, pedestrian islands. Pedestrian islands. I was somewhere the other day, I was reviewing a drawing. It's got a bus stop with a cycleway behind the pedestrian refuge area. They're all the rage these days. But in order to fit it in, the pedestrian refuge area was 1.1 meters wide. That's not enough space for pedestrians, let alone a pedestrian with a pram or a pedestrian using the adjacent crossing with their bicycle or anything. So there's a lot of, and then when you looked at it, the drainage point was right in the crossing path, so that in bad weather, almost certainly that would be flooded, and the pedestrians would actually move sideways to a point where the sight distance was rubbish in order to cross. So there's a lot to be looked at as we go through. And then there's the dynamic visual obstruction, other vehicles, in other words, typically blocking your sight distance. The Austroads Part 6 has prompt lists, which have considerably more. And I'll talk about prompt lists in a minute, because that's the last thing on my presentation. I was just going to talk about some of the mid-block issues and things. I think these are all reasonably self-explanatory. Skid resistance issues are, of course, very difficult to see. Pavement defects are very easy to see, but typically for a lot of things, they are not, depending on what they are, as big a safety issue as some people would like to think, but certainly for some users, pavement defects are. One that I find particularly annoying is the flow of detritus from driveways and things onto the highway, particularly in rural areas where you've got farm fences. I don't know, we've done some work in New Zealand where we found that if you seal back 11 meters, you generally reduce the amount of detritus that ends up on the pavement, which is really important for motorcyclists, because there's nothing worse than coming halfway through a bend and finding there's a pile of detritus across the road, and next thing you know, it's all over and things. And finally, in the prompt lists or checklists, as they used to be called, the Austroads Guide has very comprehensive prompt lists, but they're hierarchical, and when you first start off safety auditing, it's worth having a look at all of these individual questions and actually going into detail in the prompt list. After you've been doing it for a few years and things, you can probably just remember adjacent land use, public transport, pedestrians, and you know the questions that you should be asking yourself. But do not ever be afraid to use the prompt lists. One of the things I like about doing, and I used to do regularly with my prompt lists, was using them before I left site, because there's nothing worse than leaving the site, getting back to the office and starting to write up and thinking, oh shit, I never got anything on that. And then you're either faced with a 2-hour drive out to the site, or writing some sort of waffly nebulous comment, or asking somebody to have a look at it on their way home from work. If you sit down and you use the prompt lists at the end before you leave the site, you'll pick up those things. The other thing that I'd like to say is, in this day of technology, digital photographs and snips from the design drawings, you pull the PDF up, you take a snip, or you take a digital photograph if it's post-construction, you can save yourself paragraphs and paragraphs of writing. Instead of writing at chainage 475 on the left-hand side, 3 meters back, there is, you can say, see figure 2. And it makes it so much easier. It's so much less likely to be misunderstood, and people can see your problem while you're there. So I think it's really important that you actually use the digital technology as much as you can to take, it's even worse when you're using design drawings, you know, to try and explain that on sheet 37, it's such and such and such and such, whereas you can take a snippet out and just go, this is what my problem is. You can annotate it if you want to for your sight distances. It makes it so much clearer for the reader and so much easier for you. And Ken, I've finished.
Yeah, well, you've just given a couple of wonderful tips for their assignment coming up, because they do get marks taken off if there's not a little snip in of the design or a photo there to highlight that to make it easy for the reader. So some good advice there. We do have a couple of questions though before you finish up, Ferg. So
Yeah.
one's come in around the swept paths tracking there. Do you expect the audit team to undertake their own swept path analysis, so run their own swept path, or do you accept what the design team gives you?
I usually get what the design team give me, but I always ask for what was the negotiation speed and why did you choose the vehicle that you're doing? The negotiation speed is really important. So, I mean, unless they're really being dishonest, you should trust what they're doing, but you need to know those other parameters. And they can be quite illuminating. As I said, the one that I had the other day, it is 5 kilometers an hour is walking speed. You're asking somebody in order to make this maneuver to turn across 2 lanes of traffic in a filter turn at walking speed, bugger off. It's not going to happen. And when they went faster, they couldn't stay within their parameters. So, you know, it's quite simple.
Yeah, I absolutely agree with that. Finding out those parameters is very important. And as like one of the ones you showed there, I think sometimes you can just by eye go, well, that looks off. There's something odd about it. It's taking a sharp turn, or it doesn't look right. And then that might be a point where I get somebody to run the swept path.
If it does something kinky in the middle, you know, and you got to think, how would you drive it? I suppose I'm a little bit lucky because I used to drive coaches, and I've got a good feel for it. But you can ask that yourself. How would I drive it? Why would I go over there and then come back in order to get around there? It doesn't make sense. It's not going to happen.
Yep. No, very good. Another question around the crossing sight distance. So crossing sight distance at pedestrian crossing points, refuge islands. So that's really set up, I suppose, for the pedestrian having time to see a gap and make that judgment and cross. Do you use the same, or would you use the same or look for the same at a pedestrian operated signal, or even the next step, I suppose, at a pedestrian priority crossing, a zebra crossing?
Right. At a zebra, the minimum that you should be providing is the safe stopping sight distance.
Yep.
So, because at a zebra, the onus is on the vehicle to stop when that person uses it. So they should be able to see a vehicle, and just as if they step out just in time, the vehicle should have time to stop. But I think the important thing is that you should probably be using a longer perception time, because even though we signpost our zebra crossings in advance, which in theory should allow the driver to be more aware and therefore us to use a lower perception reaction time, we know that signs are not picked up properly. I don't know if you're aware of some of the research that Sam Charlton's done on which signs are recognised and which aren't. I think the most common ones were school and roadworks, which had about 15 or 20% recognition when they appeared in a scene, compared to McDonald's, which had an 80% recognition. Other things like, I'm just trying to think of some of the other signs that he used in the experiment. I think some of the uneven surface and curve ones were never even hardly noticed, less than 10% of the time. And he did another really good experiment just recently where he had people drive the same piece of road time and time again. And then he changed all of the signs to German and nobody noticed.
Right.
But
Fascinating.
yeah, and I think of this because when I used to work at Opus Research in Petone, I used to drive along the Esplanade day after day after day, and there was a zebra crossing there, and nobody ever went on it. And I always used to think, you know, you're supposed to have a minimum crossing volume for it to be recognized. And I was thinking about that one day when somebody actually stepped onto the crossing and I nearly hit them because I was so unexpected that I had driven this route every day for years and nobody had ever used the crossing. I nearly took them out. And so, you know, this idea that you can sign it and then pull down your perception reaction times, complete load of rubbish. Unless it's really, really, really heavily used. So yeah, and then for signals, again, what you're looking at is the sight distance for the drivers to the signals, because the crossing person is controlled by the signal. So they get told when to go effectively. Okay.
Yeah, no, that's very good. I suppose another one on that is around the raised pedestrian crossings and trying to work out an 85th percentile approach speed on that. Is there any, do you know of anything on that? Most people I seem to just use a conservative approach of saying, well, we'll take the free flow design, the free flow 85th percentile speed without that taking into account the raised part of it. Do you know if anybody's ever sort of worked out using that fact that a vehicle will slow on the approach to a raised area?
I'm just trying to think. I don't know of anything off the top of my head. There was some work done a few years ago by Auckland Transport looking at the spacing of speed humps down a road and what the optimal spacing was. I can't remember the details. It was actually very close. In order to keep that sort of mid-block between the humps down, they needed to be spaced really closely. Typically, we've been looking at, you know, people see the hump. They generally know that the hump is 25 or 15 Ks, depending on or 30 Ks, depending on what the ramp is, but they can't see the ramp, but they can see it coming, and they generally pull their speed down. So we've generally been looking at the sight distance based on them coming in full belt, but expecting that when we're looking at what's going on, there's two things going on. One is that you're hoping that with the hump and the speeds coming down, you're reducing the crash likelihood, and secondly, with the speed down, you're dramatically reducing the outcome should something go wrong. It's all very interesting at the moment. We've got a number of places coming where they're crossing two lanes of the same direction with a zebra, which I'm dead against, but by putting them on a hump and a crossing, it seems to be working. Now, I think I've seen somewhere, I think it might be you, Ken, suggest that the two lanes should be separated with a refuge. We haven't done any of those in New Zealand yet. It'd be interesting to see, but certainly the sites that Irene and Ron Minima have been putting in Auckland and Porirua, they do cross two lanes of the same direction with a zebra when it's on a hump, and it seems to be working reasonably well. One of them I've been on, which is at the end of a 70K area. It's a little bit nerve-wracking, I'd have to say, because the speed limit changes just right next door to the crossing.
Right.
I think this is one of those things to meet the standard. You know, you change the speed limit and you've got to ask yourself, am I meeting the standard or am I making something safe? I've seen another one recently where they dropped the two-lane approach to one lane 20 meters in advance of the crossing. So the crossing is only crossing one lane, but it happens to be at the point where the vehicles are trying to merge. And you've got to ask yourself, you know, I've got a vehicle next door to me that's trying to merge with me, and I'm supposed to be looking for a pedestrian over there. Yes, it meets the standard, but is it safe? Probably not. And that's, what you're looking about. When you're doing the audit, you're saying to yourself, I'm going to be focused on these vehicles merging, and I'm not going to be looking at where the pedestrians are coming from, or indeed the cyclists from the school in this case who ride across the crossing. They can come onto the crossing so much faster than a pedestrian, because even though the law says you're supposed to get off your bike and push it across, bollocks, it happens. They just belt across, and you've got to be aware that you need more sight distance in that situation, because they can come on to you much faster than you would expect.
And they're wonderful examples of exactly what road safety auditing is all about, isn't it? It's pushing aside the, just getting compliance with standards and saying logically, is this going to work? How are people actually going to use this? Where's their attention going to be? And then looking at mitigation measures to try and reduce that risk. So wonderful. Now, it doesn't look like there's any other questions that have come in there, Ferg. So thank you so much for taking us through that. As I mentioned at the start there, Ferg's contact details are in your slides that you can download from the Learning Management System. So please, if you want to follow up with Ferg on any of those things that he mentioned, or just catch up with him for a wonderful chat, as it always is, I suggest you reach out to him.
Yeah, I'd love to hear from you.
Great. Thanks, Ferg. And we're going to take a 5-minute break, and you've probably got some auditing to do yourself, Ferg. So we'll let you head off now.
Thanks very much, Ken. Have a good day. Thanks.
Thanks,
Bye.
Ferg.
Bye.
Okay. We're going to take 5 minutes now, everybody. So have a stretch, fill up your water. We'll be back, and I'm going to take you through a few little bits of content, but not a huge amount. I'm going to then introduce the assignment to you, give you a few tips on that, and then I'm going to give you time to get stuck into the assignment. So back in 5 minutes. Okay, we'll get back into it. I just thought I'd elaborate a little bit on what Ferg was talking about with dynamic visual obstruction on the approach to pedestrian crossings, because I'm just working on some content for our raised crossing course, but hopefully you can see that there. The idea here is that we've got the pedestrian crossing of some description, and I've used a 3-lane crossing here just to illustrate it, but sight lines are blocked for that following vehicle across those areas there. So that's why we don't do pedestrian crossings on multi-lane roads, is the general guidance. But Ferg was mentioning there that raising the crossing significantly reduces the issues there. And the one I was talking about, or he was mentioning there, was the idea of utilizing some road space for a refuge island can then open up enough sight lines there that the pedestrian can be seen. So that's just to fill in a bit of the gap there. And we were just talking in words about it. I thought I'd show a few of those pictures that it might help some people visualize that. Okay, I'm just going to get my other slides up and running here, and we will. Okay, so Ferg mentioned prompt lists, and prompt lists are a really helpful thing as you start out auditing. Now, they the Austroads Guide, so the 2022 version of the Austroads Guide to Road Safety Part 6, Road Safety Auditing, has these different prompt lists within it. As mentioned, they used to be called checklists, but we wanted to avoid people thinking that if they just followed through every one of the questions in there, that they'd done the totality of the job. We really wanted to ensure that people thought these are just to prompt your thinking, to start the thinking process, asking different questions. The Austroads one now has this front-loaded prompt list at the start, which has these generic questions. And you can jot yourself down some thoughts and answers, but this is to help you set the context of your thinking as an auditor. Okay, so you can see there different questions around operating speeds and impact angles, vulnerable road users, are they in the area? How does it fit in a network planning context, and a few other things. Really just to help you gather the context of the project. The prompt list H3, 4, 5, 6, and 7 then have these sort of specific elements to them. Local alignment, general aspects, intersection, walking and cycling, traffic signals, lines, marking and lighting. So you will use multiple ones of these, and you can see each of the columns are the different stages of audit. So if you're doing a feasibility concept, which most of you will be doing for your practical audit component, you'd use that column, and then you've got these questions here. You can tick boxes if you want, but it's just to get you thinking about these different things. In the New Zealand guidelines document, the 2013 document, pages 43 to 53 contain checklists. They're still called checklists there. In future versions, I think they'll be moving to prompt lists as well, but they also have questions. So you've got quite a good amount of material available. But I do put here as just some reminders. Checklists are thought starters only, or prompt list is a good name for them to remind you of that. Look at the project in its totality, stand back, look logically about it. You might find things completely not mentioned in any of these prompt lists or checklists that you are concerned with as a safety issue, and that's what we want put in there as well. There'll be a lot of stuff in there that's not applicable. huge amounts of it will be not applicable, because we're trying to cover off, all of these road scenarios and road upgrade things in these prompt lists. So you'll just be sort of going, yeah, that's not applicable, not applicable. Okay, that one's interesting. We hadn't thought about when it's raining, how this would all look, or something like that. And here you do not submit these checklists as part of a road safety audit. They're there for you in the background. They're a tool to help you do the work. You simply submit the audit report with the ones that you believe are issues. So nobody sees all the things you thought about and you considered and you decided aren't issues or anything like that. It's simply, what are the issues, and you present those in the audit. So hopefully that makes sense. Happy to answer questions on prompt lists, checklists and the like, but we've got those either in the Austroads document, which is in the resources part of the learning management system. I'll show you that shortly. Or both these documents are in there with the checklists embedded in them. Okay, so you are going to start now practicing writing audit findings. Okay, and the important part of this assignment is about you utilizing the formula or recipe we gave for what should be included in a road safety audit finding and risk rating and providing recommendations and safe system categorizations. And the way we're going to do this is to give you a design and then a bit of vision from the existing site. So it's a little bit of a mock road safety audit. You're not really going to the site, so you would never call this a real audit. You never get the full context without actually going to the site. But we're getting things a little step forward. And you would have got in your pack, hopefully, or you may or may not have, some 360-degree goggles. I can't remember whether they had got them to this group or not, but it doesn't matter because you can use your desktop or your phone anyway. I'll show you that. So what we're going to ask you to do is look at this design. And the design here is of a roundabout that is being removed, sort of an egg-shaped roundabout that's being removed, and a set of traffic signals is being put at this intersection to replace the roundabout. Okay? So what your role is to tell us the safety issues of the signals when they're built. So they're not there at the moment, but when they are built, what are the safety issues that might be there? So you can see there, we've got Canterbury Road here, and it's got multiple lanes coming through. Currently, there's a roundabout, but in the future, it's going to be signalized. You can see the signals. We've got bus stops there. We've got Montrose Road coming in here. We've got a slip lane. We've got pedestrian crossings there on it. Currently, no slip lane there because it's a roundabout. You've got some shops down here. You've got the lanes coming through here, right turn lane, each there, right turn lane there, slip lane. Okay, so that is what is being built. You are to imagine that being built, sort of put yourself into the future and say, okay, I can see all of this now in my mind. Now, what are the issues that may arise from a road safety perspective? There's a couple of extra sheets to lead in to this intersection, so you've got that. So you'll be given these designs to have a look at. Real designs. We didn't make, haven't fabricated these. We just simply took a design that was done by a large design consultancy and have run with it. Okay, but we want to give you a little bit of vision, a little bit of site visit replication. It's not real site visit, but it's getting us a little bit of info. So what we've done is we've put a 360-degree camera at each of these locations and you're able to click on them and it'll drop you there and you're able to look around. Now, as I say, if you do it on your phone, you can just move your phone around and it's like you're there. And if you put it into one of those goggle things, your phone into there, you can look around, look up, look down and around like you're actually on the site. If you can't do that, not to worry at all, you can simply just click on one. We'll jump into the roundabout. We'll have a look. We'll have a look here from 5. We'll jump into that. Here we go. And I'll have to mute this. Oh, there we go. So hopefully you're seeing that now. There we go. We're in the roundabout. We can see it all operating. And then you can just drag around. You can look up in the air if you want and see what's going on. But you're able to see how it's operating, how it's functioning, where pedestrians are walking, and you're able to look around there. So you get a couple of minutes of footage of each of these. And that's sort of to give you an idea of what's currently there. But remember, we are auditing not what's currently there. We're auditing what will be there in the future. But why do we then go out and look at the site? Well, we look at how things tie in, where pedestrians are crossing and going to, how vehicles are using the road, what type of vehicles are there, you know, what the land use is, where vegetation is, where crossing desire lines are, what sort of angles are existing now and are they going to change? You know, is there roadside furniture there at the moment? How, you know, will that be in the future? Have they factored all of that in? So that's why we have a look at the existing site, even though we're auditing a design, a future scenario. So we want you to do that. We've given you a bit of information here on things like traffic volumes, CV is commercial vehicle, so 7% commercial vehicles, 3%, 9%, 2%, and yeah, that's the road there. So you'll be able to jump in there. So maybe, you know, at 12 here, let's have a look at what we get at 12 there. Okay, so we're seeing now a shopping area. Oh, looks like a little walk through there. We've got people all around there. It looks like, oh, buses. Okay, we're gonna have to think about how buses are gonna go through this new area. Looks like there's something over here as well. I wonder whether pedestrians might want to go this way. Okay, there looks like a signalized crossing here. Wonder if that's being factored into the future scenario. So that's the kind of thinking we want you to be doing. You've got drainage grates, vehicles making that movement. Will they be able to do that in the future? Are there safety issues associated with that? Okay. So in the learning management system, and I'll take you in there shortly, you will get a one-pager, which is it's the instructions. So it tells you what the task is. Look at the designs, review the footage, find 2 road safety issues, 2, I only want 2, and then write them up. And we've put an example in there. You can see a snip of the design, circling the issue. It's from a completely different site, by the way. So, you know, but then explanation, following the formula, recommendation, categorization of that into supporting or primary, risk rating here, common, unlikely, moderate risk. Now, that is the New Zealand Road Safety Audit template document, so you'll start to get familiar with using that. I'll take you through that shortly. You've got the risk matrix here. So, you know, if you think it's going to be common frequency that crash happens and it's likely to result in death and serious injury, the risk is significant. So that would be common, likely, significant. In this case, it was common, unlikely, moderate. That's common, unlikely, moderate is the risk. Okay, so I'm going to jump into the learning management system now. I'll stop sharing, and it's probably a good opportunity if you have questions. I think a question has come in. Okay, so is there a phasing diagram for the signals? No. So you're not going to get all the information you'd like. We're not going to give you a phasing diagram, so you can make assumptions. We're okay if you just make some assumptions, and then maybe in your findings say, we've assumed this, or I've assumed this, and that's an issue. Yes, so there's a lot of things that you would check in a design like this, but we wanted to try and make it quick and easy, and so you just need to find 2 issues only. So I'm just going to now jump into the learning management system. There we go. Okay, so learning management system here, resources. You can go to reference documents here, and you've got the New Zealand procedure. So, and on page, I think it was 43 to 53, you can find checklists. And then you've got the Austroads Guide Part 6, and in there at the back in one of the appendixes is a good sort of 15 pages of prompt lists. So you'll be able to find those and use those. If we go a little bit further down here, so hopefully you've uploaded your research assignment. And again, thank you, just some absolute belters in there. Just, yep, was laughing out loud at multiple times for the creativity, and then thinking, oh, they've really summed this up nicely on a few of them. So I'll give some prizes out. I think I could have given prizes to everybody on this one, but I'll pick a few. And module 2 stuff, and module 3 here. So you've got a quiz to do, but then you've got this, writing road safety audit findings. So we click on that, and you can see there, we've got the functional design. So that's the actual design. I'll open it up now, hopefully that'll, there we go. Functional design, there it is. The actual design for you to look at. Remember, that's what you're auditing. You're not auditing the existing conditions. You're auditing what is there, what is going to be there, I should say. So we've got that. We've got the 360-degree filming links to the cameras. So you get that document, and you can see they're all hyperlinked, so you can dive in and have a look. And you get the Word version of the actual assignment, because this is where you're going to write it in there. Just open this up. Oh, you got. Okay, so hopefully you can see that. There's the task. There's some tips here for you. And I suggest you read this. We have a lot of people just jump straight in and haven't read it. We've got the example to help you out. And then you see there's only 2 pages there, because we only want 2 findings. Type a heading in, put a subheading in, risk rating. There it is. These are exactly how the New Zealand template is. So you're getting some practice using it. It doesn't automatically give you the risk rating, so you've got to check that and that here come up with the right risk. So frequent, likely, serious. We change that to serious. There we go. And you write your finding, put your SNP in, make your recommendations. Have a go at this, primary or supporting. That's going to probably be the biggest challenge for most of you, is trying to figure that out. Remember, the big impact changes are primary. Supporting are all the things that are good, but aren't going to give us that big step change. You can go to the Austroads Safe System Assessment Framework if you want some lists of things to help you through that, or get in contact. Look back through the slides from earlier modules as well. Once you've done all of that, you've rounded out some nice findings, PDF the document, and then upload it back into here, add submission. Add submission, upload it. PDF it if you can. It just makes it a lot easier on our end. If you can't work out how to do that, or you're having trouble with that, the Word document, we will be able to handle that as well. It's due at 5 p.m. on Thursday the 18th. So we want you to have a go at this because your next assignment is this expanded a little bit more. So we want you to practice getting all of this writing right, and then it's going to really help you for that actual audit you're going to do. Any questions about your task here? Okay, I'm doing well. Okay, in that case, what I'm going to do is let you now get stuck into the assignment, do your quiz, and if you are yet to finish off that research assignment, it shouldn't take you too long. You've got half an hour now. That should be enough to knock off this assignment because we don't want you doing more than 2 issues. I may just give a little few hints to people here. Think about pedestrians, where they're going. Think about what angles vehicles might need to look at as they're approaching the intersection or making decisions around the intersections. Think of those angles. Think of where buses are stopping. Think of where turns will be happening. So there's a few little clues as you're ticking along if you struggle to if you're struggling to find issues. There's plenty to think about in there. Of course, though, if you're really struggling, get in contact, shoot me an email, we'll organize a time, and I'll walk you through some of this. Okay, well, thank you very much. Jump in there, and this is a great opportunity to get yourself back in the timeline of this course, finishing off your quizzes and the assignment. So thank you, and look forward to seeing you at the next module where I'm going to give you your actual mock audits to do. Bye.